an alpha like 0.025 or something, would you, and you're using z-scores, would you want to use the z-score chart, or could you just do like the t-score chart but go all the way down to the bottom?
Yeah, as long as it's a percentage that's on there. And officially for us, if it's anything over 2,000, we're going to use large. We're just going to use z-scores then. Yeah. So, when it gets to that range, they're changing so little from what a z-score is, we basically just use the z-score. So yeah, if I give you a problem where I took a sample of 3,000 whatevers, and you're going to use a z-score. There's no question.
If you have like a sample of like 1,000 or something.
Well, then that's on the z-score, the t-score chart, I think, right? Pretty sure it goes up to 2,000, right? And then it's like large is after that. Yep. They have 1,000, 2,000, bless you, and then they have large. Sounds like the coffee sizes. Like going to Einstein and I could say medium. It's like, yeah, I can say medium. You won't look at me weird. Unless one of you guys work there. You guys look at me weird all the time. It's all right. Anything else about confidence intervals, hypothesis tests? Specific and general? I ain't got nothing, so I mean, it's dependent on what you want to ask. You guys are so funny. If you're all ready for the test, there's no reason to sit there and stare at me, right? Yes?
What would you go on doing on practice 1B?
Yeah, what do I have to use for 1B? What's the variable for the thing I don't know in 1B? No, what's the variable that represents the quantity I don't know in 1B? N. So I probably want to use, and see, I won't teach it this way. I showed you the derivation of where it came from and all that stuff. But I probably want to use a formula that's solved for N. Does that make sense? That's kind of a way as a student you go, okay, that's how I can tell which formulas to focus on. Now from there, is this a percentage one, or is this one where I know the standard deviation and it's the one where I know standard deviation. So I'm going to use not the one with p hat and q hat in. I'm going to use the other one. So it's going to be the n equals z squared, sigma squared over e squared. E for 1b is going to be 0.5. I like it. Let me give you the answer key while I'm thinking about it. That's what you guys are all waiting for. Just say, hey, give us the answer to that. Oh, shit.
Did you put 0.5 for E because you didn't know you had a p-hat, so that's what you guys guessed?
No. I put 0.5 for E because it says 1/2 an hour.
1/2 an hour.
Yeah, I want to be within half an hour. If it said within a quarter of an hour, well, that's 0.25. Oh, yeah. So, what's the p-value associated with the hypothesis test? Where's the p-value come from? No, that's p-hat. P-value comes from your z-star. If it's two-tailed, you double it. All right, I lost count. Let's just see what happens. So, I mean, if you do a hypothesis test and you end up with z-star equal 1.8, you look up 1.8 and do 1 minus that area because it's going to be above that. That's where the tail is going to be. That's the p-value. And that's what they report in journal articles and all that kind of stuff. They report that. So if I do a whole test, let's see, I do a one-tail test, and I get a z-star of 1.8. So what's that area going to be? So remember, alpha is the area in the tail of the critical z-score, right? 1.96, 2.326, all those numbers that we should be used to by now. My Z star could be any freaking thing. It depends on the sample. But the p-value is to my Z star as the alpha is to the critical Z score. If your people understand the analogy. So alpha is the area in the tail of the critical Z score. P-value is the area in the tail of my Z score. That's it. So when you look at 1.8, you get 0.9641. Oops. So what's the p-value going to be? 0.0359. 1 minus this. The area in the tail. Now, if this would have been a two-tail test, I would have just doubled that to kind of account for the fact that alpha is cut in half, and then I double it to make a whole alpha. So then I double my p-value to be able to compare it. So that's where the p-value comes from. It's just like alpha, except it's the area for your z-score, your z-star. Yeah.
Number 2, how do you find your z-score? Or it says.
Oh yeah.
97.
You got to do it the old-fashioned way. Before we knew about z-score chart and all that shit. What's 97% confidence mean? There's
3% outside.
There's 3% outside. Yeah. 1.015. You try to get as close as you can to that.
So you use a z-score.
Yeah.
To find that.
Yeah. I'm not going to be able to give you a t-score problem that has a weird percentage because that would require technology because our table isn't that detailed because it can't be. Holy shit. We would need a detailed table for every degree of freedom there is. That would be a little much to carry around. But I will feel completely fine giving you like a 91% confidence